Hey, thanks for joining me. We're going to complete the square again in the context of taking an expanded uh, equation, an equation for a hyperbola or a parabola that's been expanded out, so it's not really useful. Can't really tell anything about that, whatever the shape is, hyperbola or parabola. And so we're going to do completing the square to get it into a shape that we can analyze and make use of. All right. So here we have 4x squared minus 9y squared minus 16x minus 54y minus 101 equals 0. There's our equation. Um, what is this? What shape is this? We can kind of tell right from the beginning, we can tell it is a hyperbola because the x squared and the y squared are being subtracted. Um, the coefficients are different. I don't know if that matters, but they're being subtracted, and so that's what's kind of going to clue us off here. Okay, let's see. We want to, as always, gather our like terms together. So 4x squared minus 16x, and then minus 9y squared minus 54y, and we'll move that number without a variable to the other side. So equals, add 101 to both sides. Okay, now we're going to divide by the coefficient of our x squared and our y squared. So we're going to factor out the coefficients on our next step. So just divide out 4 from both x terms, so 4 times x squared minus 4x. And then we'll leave some space here. And factor out a negative 9, it's minus 9y squared, so minus 9. Divide out negative 9, we get y squared plus, let's see, I think that's a 6y. And then we'll leave some space, equals 101. Alright, so now we're thinking, what are we adding to complete the square? We have to, whatever we add to the left side, we add to the right side. So we take half of the coefficient of the single x to the first power, half of negative 4 is negative 2. Square that, negative 2 squared is positive 4. Alright, now, we would normally just add 4 to the right side, but we have to think about this. We're not really adding 4 to the left side. We're adding 4 inside that parenthesis that's going to be ultimately multiplied by this 4 that's outside that we factored out. So we're actually adding 4 times 4, which is 16. So we're adding 16. And again, we'll do the same thing for the y. So take the coefficient of the y to the first power, 6, divide by 2, that's 3. 3 squared is 9, so we're adding 9 inside the parenthesis. Which really means that we're adding 9 times this negative 9 out here, so we're adding negative 81. So I'm going to add negative 81 to the right side as well. Okay, I think that's the trickiest part here for this type of problem. Now we'll complete completing the square, we'll finish that off. This is x minus 2 squared. Again, half of negative 4 is negative 2. And that's being multiplied by the 4. This part is y plus 3 squared. Again, half of the 6, positive 6. And it's being multiplied by negative 9 equals, add this up here real quick, that's 101 plus 16 is 117 minus 81, that is 36. Okay, well, little hint on the side here, this number should add up to, if we're going to have coefficients in all the key spots, this doesn't always work out, but if we're going to have coefficients in all the key spots, then this number here, 36, should be this number times this number, 4 times 9. So that's for an easy problem. Now, if it's a real world situation where there's a lot of decimals going on and whatnot, roots, square roots and whatnot, that's a different story. But if this is kind of an easy kind of textbook problem, then that's a clue that you've done all your adding and subtracting and multiplying correctly. Okay. The last step then is we want this to equal 1, so we're going to divide by that 36 here. We'll divide each term by 36. And that's going to give us fractions. So we'll cancel out the 4 with the 36. 36 divided by 4 is 9. So that's going to be x minus 2 squared over 9. And then we'll cancel out the 9 with the 36. That'll leave a 4 in its place. So minus y plus 3 squared over 4 equals, of course, 36 divided by 36 is 1. And that's our standard form for a hyperbola. Oh, let's see. I hope I don't say this wrong. I think if the y is, the x is first, I think that's the one that opens up and down. I may be wrong on this. That may be open left and right. So we have a center at at 2, -3, 2, -3 right there. In the x direction, we're going to go over 3 spaces. And in the y direction, we're going to go up and down 2 spaces. That creates our diagonals, and then we can put in our vertices there and create our hyperbola. I think that's right. Definitely check your notes on that one, because I don't have my notes in front of me. Okay. That was how you did the completing the square. That can be really tricky just because there's so many different little bits that you have to multiply correctly, add correctly to get it. So let's try another one. This one will be the parabola. Okay, so in this last example, I don't know how often you're going to see one of these expanded out like this, but just for fun, I'm going to take this time, because I know that it's a parabola because we have a y squared term, but we don't have an x squared term. We just have a single variable x. So I'm going to move the x to the other side. Maybe I'll move that 69 over there too, and just gather all my y terms together. So y squared plus 6y, leave some space, equals, add 12x to both sides, subtract 69. Okay, so we're just completing the square one time here, which makes that a lot easier. And there's no coefficient other than 1 in front of the y squared, so that's going to be easy. We'll just do half of 6 is 3. 3 squared is 9, so add 9 to both sides. And that gives me y plus 3 squared equals 12x minus, let's see, negative 69 plus 9 is negative 60. Okay, so more or less there where we wanted to be. We would rather have that x be by itself. We want an x without the 12 in front of it. So I'm going to come in here and I'm going to divide everything by 12. So divide by 12. Divide this by 12. We'll divide this by 12. And just to add confusion, I'm going to just swap sides. So the 12x divided by 12 is just x. Negative 60 divided by 12, I think, is minus 5. equals, now instead of trying to figure out what is y plus 3 squared divided by 12, I'm just going to write that as 1/12 times y plus 3 squared. And so hopefully you recognize that that is a parabola with a vertex at the point 5, -3, so 5, -3, let's say, is right there. It's x equals y squared, so it's going to be opening to the left or to the right. That 12 is positive, so it's going to open to the right. It's going to look something like this. We can do some stuff with the focus. We'll figure out what the focus is. I think 1/4 p equals 1/12. So p equals 3, I think, in this case. So the focus would be 3 away, and then the directrix would be there, and we can do some more kind of careful plotting to figure out exactly how wide that parabola is. I think it would be fairly wide, but I'm not going to go into the details there. That's for another recording. This is how you use the completing the square process to help you transform your conic sections. And if you didn't watch the first recording on this, look around for it. I've done a recording which covers the circles and the ellipses as well. Thanks for watching.